Hello. Welcome to Team 8's senior project, an electron-tunneling microscope. This project was sponsored by Grand Valley's Physics Department and Dr. Joshua Veazey. The faculty advisor for this project is Dr. Carl Bercora. The members of this team include Nathan Koch, Dustin Matthews, Sean Folo, Jacob Kaczynski, Kelsey Marquez, and Megan Sikora. Professors in Grand Valley State University's Physics Department first introduced a novel design for a single-axis electron-tunneling microscope in 2022. Following a further design iteration, the GVSU Dewar Center produced several functioning prototypes that have been used in the laboratory by advanced undergraduate physics students. The GVSU Dewar Center, in cooperation with the Physics Department, has sponsored a senior design project to revise an electron-tunneling microscope with the intent to 1. Improve the speed of data acquisition. 2. Reduce the cost per unit. 3. Reduce the setup time. What is an electron-tunneling microscope? It is a simplified, single-axis instrument. The device allows the students to measure surface energy states of different materials. It requires extremely small-scale distances and currents in order to function properly. In order to use the electron-tunneling microscope, first, it must be set up by placing the tip and sample and making connections. Then, coarse and fine adjustments are performed. Finally, the user must interact with the GUI to control the microscope and collect data. These are the key specifications for this project. Some of these include: the total cost of all 5 devices must be less than or equal to $5,000. The tip must be capable of moving in delta Z steps less than or equal to 0.10 nanometers. The device must use a distance control algorithm to control the tip's approach to the sample. The GUI must display currents, voltages, and approach distances. This is the 3D design for the electron-tunneling microscope. It shows all of the components required in order to function as planned. This is the fully built electron-tunneling microscope for this project. The 2 micrometer screws on one side are used for the coarse adjustment to the sample, while the micrometer screw attached to the stepper motor is used for the fine adjustment. The fine adjustment allows for the tip to approach the sample in order to achieve the desired tunneling current. Thank you for listening.